So there's the informal definition here that has that visual that we're used to, that's the idea that the terms of the sequence eventually get close to some value of the sequence L. And typically that's happening, it could be that the values are oscillating around and then approaching L, or that they're sort of scooging up on it from the top or the bottom. The formal definition is the one here. So it says that we can always say, if I know it's the limit, then you tell me how close I want to be to that limit, and I can tell you we'll only pick terms beyond a certain point in the sequence. And so I thought it would be helpful to look at an example like that, just so that that has a little bit of meaning. So let's say we took the sequence 2 minus 1 over n squared. Okay. So I'm going to claim that because I know that the function 2 minus 1 over x squared converges to 2, and I know that because the limit of the number 2 is 2 as we approach infinity, and as x approaches infinity, 1 over x squared, we're dividing by larger and larger numbers, therefore that's going to shrink to 0, and so this is 2 minus 0, which is 2. So since this is the way the function behaves, and the reason I'm using x here is to indicate that's a function where I can plug in any real number, then anytime the limit of a function at infinity is known to be a finite number, then the sequence itself will also approach that number 2. So sort of intuitively we've said the limit is 2. Then if we wanted to use that definition to talk about, well, actually just how close far out in the sequence would I have to be, I could say, oh, well, maybe let's let our epsilon be 1/100th. Then this statement's saying I should be able to take a term of this sequence, so a term of the expression 2 minus 1 over n, subtract the limit L, so this is the a sub n part, here's the L, and the absolute value of that will be less than my 1/100th for some number n and every n value bigger than it. So looking at this, inside that absolute value bar, you can see we have a negative 1 over n once we take the 2 minus 2. So that's just 1 over n, since n is only positive numbers. So we're just solving for the first natural number n that's less than, oh, I wrote n, it's n squared, isn't it? The first natural number n such that 1 over n squared is less than 100. So in order for the fraction to be less than 100, I need n squared itself to be greater than 100. So the first counting number whose square is bigger than 100, well, that means that n has to be bigger than 10, and since I'm only taking counting numbers, I'm going to set that capital N here. In my example, it would have to be 11, because once I plug in any capital or n equals an 11 or any number bigger than it into that sequence expression, I will be within 1/100th of 2. So that's what that definition of the limit part means. And that's a typical way that I would have you show me that. I could say, use the definition of the limit of a sequence to determine the n value for which we're within epsilon equals 0.0025 or something. And it's this algebraic process that you would go through.